scale SpiNNaker machine is a big machine sitting in a server room in Manchester, and similarly, the BrainScaleS large wafer scale machine sits in a room in Heidelberg. So how can you access these machines? Well, you can do so through EBRAINS, through your web browser over the internet. So for more information on this, you should start by going to the EBRAINS homepage at ebrains.eu, click on Services, and then BRAINS Biotechnologies, and this will take you to this page here, where you'll find all the information you need about how to access BrainScaleS and SpiNNaker. Before doing that, you should probably, first of all, if you don't already have it, register for an eBrains account, because you will need that to access the systems. So when you're talking to SpiNNaker and BrainScaleS, how are you programming them? How are you telling them what to do? And the standard approach for this is to write a Python script using the Pine API. So Pine is a common language for describing spiking neural network simulations, and it can run the same script on Nest, Neuron, or Brian for software simulators, or on BrainScaleS or SpiNNaker for neuromorphic hardware. And so a single input format like this, so this is the code setting up your populations of neurons and recording from them and then connecting them together according to some rule. And the only code in principle you have to change, BrainScaleS is a bit more complicated, but in general, all you have to change is the first line. So either you import pine.nest or pine.brainscales or pine.SpiNNaker. And then you also get all your data in a common standard output format, which can then be processed further using tools such as Elephant. So your code is a Python script. There are, for power users, there are other approaches. You can get down into the more detailed levels of the systems as well. But for the standard use, it's a Python script. And then there are different ways to send this Python code to SpiNNaker and BrainScaleS. And these break down into two overall categories. Either it's batch mode, so you have your script, you send it off as you're perhaps used to doing for a cluster or a supercomputer. You send it off. When there's time on the machine, it gets processed and run, and the results are then available for you to access. There's also a more interactive mode where you can communicate directly with the machines through Jupyter notebooks, and I'll come on to that later on. So for batch modes, there are several different approaches, ways you can do this. The perhaps central place is the Job Manager app, which you can find either at this temporary URL here, or you can install it in your Collab. So if you have a Collab in the eBrains Collaboratory, if you click on this Create button and then select Community App and create the new page with the title Job Manager, for example, you'll get this list of apps which you can install in your Collab. And if you search, you'll find the Neuromorphic Computing Job Manager. You select that and click Save and View. And now you have this application which is embedded in your Collab. And so the Job Manager provides several functions. So as you can see, it gives you a list of all the jobs which you've run on the platform, whether it's on BrainScaleS or on SpiNNaker. If you click on the quotas link, then you get to this page where you can see, so essentially you have to request time on the machines. For testing access, this is granted very freely. If you want to do a more extensive project using a lot of time on the machines, you have to explain in more detail why you want to access it. But essentially, you just explain why you want to access the machines, and then you will be granted a quota on whichever systems you want to use. Similarly, this is also now how you submit jobs. So if you click on the plus button in the Job Manager app, it opens up this this form where you specify which version of which hardware you want to use: SpiNNaker, BrainScaleS 1, BrainScaleS 2, and so on. You then have a box for entering your code. So there's an editor directly in the app where you can enter your code directly. This is suitable for testing and for simple scripts. You can equally store your code in Git and then say, okay, please run the code from this Git repository. And this will then be cloned down to the BrainScaleS or SpiNNaker machine and run there. We're currently working on allowing you to upload code from the EBRAINS drive. And we also have in progress a graphical network builder, which will let you specify your model as a drag and drop graphical app. In addition to the Python code, you then have the command line tool, which gives you more fine-grained control, the hardware configuration box, which lets you control precisely how you want to configure BrainScaleS or configure SpiNNaker, and then tags, which are just useful for searching. And then once the job is run, you can see the results. If you click on the magnifying glass in the job list, you get this list of all the files that were created by your job. If they're images, they're shown directly in the app, the code which you submitted, and then all the details of what you actually submitted, including a detailed log of exactly what happened on the machine when you submitted that job. If you prefer to work at the command line or in a more programmatic way, all the functionalities which are available through the graphical job manager app are also available as a Python client. So you pip install HBP Neuromorphic platform. This will be renamed in future to EBRAINS Neuromorphic platform, of course. And so essentially, it's a very similar thing. You submit your job, given the Python code, the platform you want to run on, which Collab you're using for access control, the hardware configuration, and the command line. And then this will wait until the job's finished and then return you your job object, which lets you then download the data from the Python, from the BrainScaleS or SpiNNaker system onto your local machine. This has all been wrapped up as a command line tool as well. So this comes free with the Python client. And what this will do is it will, so this lets you develop on your own laptop at home as if it was, or in the office post-COVID, and run things as if they were running locally, but in fact they're being sent over to the job queue system, run on the neuromorphic hardware, and then sent back to you automatically. So if you run NMPI help, you'll get all the options which are available with this command line client. For BrainScaleS, in addition, particularly this is useful because if you want to integrate with HPC systems for more complex workflows, for example, you want to run a simulation using BrainScaleS and then analyze the data which you get from your simulation using one of the HPC machines available to the Phoenix infrastructure. And so for BrainScaleS, you can use the UNICORE client to submit jobs to BrainScaleS in the same way you would as any other HPC system. And there's more information on this. If you Google UNICORE, you'll find these links. So that's for batch access. Coming now to interactive access. So what's available now is for everyone are Jupyter notebooks running at the University of Manchester. So next to the SpiNNaker machine itself, you log in using your usual EBRAINS credentials. And then you're in a Jupyter notebook where you can actually execute Python commands individually. So Pine commands, you can create one population rather than sending the entire job at once to SpiNNaker. You can create a network, run some simulations, change some parameters, run some more simulations. And this interactive way of working is very nice in the early stages of a project when you're still exploring and trying to decide how to structure your project. Coming very soon, and this may actually already be available for developers on request, is an interactive access to the BrainScaleS systems from the collaboratory Jupyter lab. So if you go to the Collab and you open the lab, you will very soon be able to install software which will give you direct access to BrainScaleS in a similar interactive manner.